Welcome to Green Giants, Titans of Renewable Energy, the podcast where insights and innovation meet. Every episode, we dive into conversations with industry leaders, experts, and change makers, bringing you the stories and ideas in the renewable energy sector that shape our world. And now, let's jump into today's episode with your host, Wes Ashworth.
Welcome back to Green Giants, Titans of Renewable Energy. Today's guest is Jan Poetsch, founder and CEO of Arder Energy. Jan is focused on one of the most overlooked challenges in the energy transition, decarbonizing industrial heat. This is the heat that powers oil sands operations, refineries, food processing plants, pulp and paper mills, and more. And it accounts for about 40% of all industrial emissions. We'll explore three guiding ideas Jan uses to tackle this opportunity. Start with simple. If it's profitable, it scales, and break the echo chambers that keep industries apart. With that, Jan, welcome to the show.
Well, thanks so much, Wes, for the kind introduction and for having me on your excellent show here. Looking forward to a good discussion.
Absolutely. As am I. It's an absolute pleasure to have you. And as we always do, kind of starting at the beginning and your origin. So you've spent nearly 20 years in LNG before founding Arder. What sparked your move toward tackling industrial heat decarbonization?
Yeah, good question. Really, to me, there are three things that make industrial heat so interesting. The first one is the sheer size. The energy demand to satisfy industrial heat needs is larger than that of the electricity or transportation sectors in most industrialized countries.
Yeah.
So it's a huge challenge, but also a huge market. Two, we have accelerating changes in power markets, in most power markets, that enable the profitable deployment of some highly scalable and very cost-effective power-to-heat technologies that enable us to disrupt this market that otherwise has been well established. And then three, these disruptions also enable us to address two other large challenges, namely industrial decarbonization and grid stability. So industrial heat may sound really boring, but it's an area I couldn't be more excited about.
I love it. I love it. And what kind of those early days, like how did Arder sort of come to be, and what was the sort of the genesis of the company as it stands today?
Yeah, indeed. I spent about 20 years in the global oil and gas industry, mainly on LNG projects. That's where my co-founder Sarah and I met as well. That was on the LNG Canada project. Huge project here. It's the largest private sector investment in the history of Canada.
Yeah.
And we were working on commercial deal delivery, worked together there for about good 10 years. After that, I had a few executive roles with PetroChina. And yeah, these years in LNG really gave me three overall lessons.
Yeah.
And it just means whatever you want to address, flexibility really means value. That's what LNG, why do people pay for a premium product? It's like bottled water versus water from a tap.
Yeah.
Why do you pay for it? Well, if you need it in a pinch or very flexibly somewhere, you can do that without having to dig new pipes. And that's what we will see, in the renewable sectors as well, in terms of batteries, etc. The second one is business models are really important. Getting those right. And then three, the modularity really matters on project delivery. So a lot of learnings that came from the time on the LNG side there. And then when we saw the opportunity that was there on this mega trend of electrification and especially industrial heat, we decided to set up the company. It was a now or never thought.
Yeah.
And here we are today, a good 2 years after founding the company.
Yeah, that's awesome. And so when you look at the broader, kind of energy transition, and you said this a little bit, but just to expand, how do you decide just where to focus? And in such a complex landscape, there's a lot going on. There's a lot that you could focus on. But obviously you chose something that, as I said, sometimes is overlooked.
Yeah, indeed. It's a large space and lots of solutions that also make sense. Where we focus on is our area of expertise, where we can add the most value. And that's within it, the commercial opportunity identification and the deal delivery part. And we specialize on the three areas where we have a lot of expertise and that are actually very synergistic, being electricity, power to heat, and LNG still as well. These areas often represent a large part of client bottom lines, but usually it's prohibitively burdensome and expensive for the clients to maintain in-house expertise, because usually this area needs to be addressed every few years. But there's a lot happening. The areas are complex, rapidly changing markets, technologies, as well as regulatory environments. So staying on top of that is difficult to build up commercial expertise in-house, to maintain it. That's where we come in. We work as an extension of the client commercial teams, either behind the scenes or delivering deals turnkey. And the role is really identifying, screening, ranking opportunities to fill the opportunity funnel, and then structuring, delivering, and implementing those deals. And that's from VPPAs to asset development agreements or tolling agreements. It's a really nice niche in the ecosystem between the industrials on the one side and developers on the other.
Yeah, absolutely. So kind of looking through your career, as we've said, it's taken you from the massive LNG projects to now cutting edge clean heat solutions. And I want to start with why you believe the first steps in the transition should be the simplest ones, and kind of getting into these big three ideas. And first is starting with simple. And I love this concept, but you've said that's the first step. Start with simple. What do you mean by that in the context of the energy transition?
Yeah, indeed. And it's easier said than done. But overall, I mean, industry loves simple solutions. And that means less complexity, less risk factors, less overheads, simpler execution. Now, energy transition in particular, we have a lot of really well-intended efforts that have, however, led to some big complexities. We often have these really hard to understand stacks of incentives, rules, regulations, and taxes on top of all the change to the market and technologies. And then, of course, rules keep changing with different governments and evolving priorities. So then the question is, okay, how do we find the best solutions here? Because the result of complexity can often be paralysis, even though the numbers may look good.
Yeah.
And to give you an example, here in Canada, we have what we call clean fuel regulations. So if an oil and gas company, and I'll pick a lot of oil and gas examples from background, if they want to reduce the emissions intensity of the fuels they produce, if they do that, and these fuels get consumed in Canada, then they generate what's called CFR credits. These credits are very valuable. Last year, they averaged 133 Canadian dollars a ton. They've been recently trading around 170. Quite volatile, but very valuable. And they're stackable with other credits like TIER here in Alberta and so on. Now, if a refiner comes up with a project to reduce their emissions, and that project has, let's say, a 4-year payback period, so very attractive, that may look really good against these metrics. But if their customer, a fuel retailer, then ships the fuel not to Canada in year 2, but to the US market, then all of a sudden, the CFR credits are no longer generated because of the regulation, the way the regulations are designed, and a major cash flow falls away. On top of that, we had political proposals to cancel these credits. That's gone very silent lately after the elections. But then also we have very high volatility of these credit prices. So something that looks very attractive on the surface, like why don't we just?
Yeah.
And especially with these high prices, is almost impossible to bank and therefore hard to implement.
Absolutely. No, well said there. And just kind of following up on that. So why do you think companies often bypass the quick wins in favor of big, complex projects? And I'd say this industry, you're right. There's so many layers of complexity and different factors that come into play there. But why do you think that is? Sort of bypass that simple solution?
Yeah, a really good question. I think it's one of two reasons usually. It's either economies of scale or incentives. Now, economies of scale, I will call the more valid example. But to give an example usually the bigger the project is, the more economic it becomes. Mm-hmm. But if it's an integrated project, let's pick the LNG example. If 1 meter of your feed gas pipeline is missing, so you've got 700 kilometers of feed gas pipeline, a few meters are missing, your whole project is stuck.
Yeah.
If your jetty doesn't work, the same thing. So you have these integrated projects that have a lot of complexity, and where if one component blows out schedule-wise or has a problem, everything gets stuck. Now, if you pick the right projects and you address these challenges, it may still be worth it to pursue it economically.
Yeah.
But it's certainly a big challenge. But I would call that, okay, that's the one reason, economies of scale. Mm-hmm. And that comes back, hinted briefly at the learning, which was around modularity. If you can have something which has big size, but can be delivered in smaller pieces that each have value, like a solar project or wind project or battery storage.
Yeah.
Actually, you hit the holy grail there. Now, the second reason, and that comes back to the example of unintended consequences, the incentives, they can really drive complexity.
Sure.
So to give you an example, it's a bit more technical one, it's still simplified. Industrial steam. So most of that gets generated with gas-fired boilers or so-called gas generators, OTSGs, HRSGs. One approach to decarbonization is carbon capture and storage. So basically, you take the effluent stream at the end, you strip out the CO2, you bury it, and it gets cleaner. Simple done. These CCS projects are heavily incentivized. In Canada, they get up to 50% investment tax credits federally, and 12%, up to 12% provincially. So you get up to 62% investment tax credits, plus, depending on application, CFR credits, or tier credits, and so on. Now, these CCS projects, they also need heat or steam in most cases for what's called the solvent regeneration process. And again, you can use a gas boiler for it, and you get parasitic emissions, or you can use thermal storage that I think we'll touch upon more later that does it without emissions. Now, these boilers or ETS units, if they're part of CCS, they again are eligible for up to 62% ITCs. If, however, you use the same type of ETS unit to replace the gas boiler in the first place, so not to have emissions at all, no Scope 1 emissions, then with current regulation, it doesn't qualify for any ITCs. So even though this may be the simpler approach to emissions reduction, and it may be cheaper from a total cost perspective, because of the unlevel playing field between the technologies, it incentivizes industrials to going the more complex route over here. And that in turn then also drives up, unfortunately, not only the complexity for industrials, but also the cost for taxpayers.
Yeah, it's a great example and really paints a picture. Could you share maybe another example where a simple, fast to implement solution created a big impact? Kind of looking at the opposite side of that.
Yeah. Actually, I'll pick something quite different, but
yeah,
as you can tell from my accent, I'm originally from Germany and going back quite regularly. I was back this year, once to Hamburg, once to Munich.
Yeah.
And I was amazed just where you see solar panels pop up.
Yeah.
They're not only on roofs, they're on balconies, they're on storage sheds. People build fences out of panels.
Yeah.
I went to a supermarket and you can buy solar panels in the supermarket with a plug.
Oh, wow.
And it's called the Balkonkraftwerk, so a balcony power plant, literally. And under regulations there, up to 800 watt output, you can simply plug into any outlet in a house and mount them somewhere yourself. And it just feeds into your power supply at home. No permits required, only a registration through an online form.
Okay.
And you can even buy them at IKEA now.
Wow.
Now, I first thought, well, is this more a gimmick or is this material? I just looked up the numbers. And as of middle of this year, they have deployed now almost 1 gigawatt of these units, nameplate capacity. So you have nameplate-wise almost a nuclear power plant worth of these little plug-in things. They come now with storage, so it's almost turning into baseload. So they constantly turn out the 800 watts, but put up to 4 kilowatt of solar behind it. And I just thought, well, here's a really simple thing. No subsidies on this. They're completely unsubsidized. But okay, power prices are high. Payback period 2 to 4 years. And on your trip to the supermarket for a few $100, you buy like a small system, plug it in, and it starts having a real impact.
Wow, that's absolutely incredible. And I think that's probably a perfect example of it, right? And there's probably so many more that we could be doing that are like that. Switching over a little bit to just thinking about Alberta, where you are, so industrial steam demand is about 3 times larger than the total electricity demand. How does that reality shape where we should focus first? And what are your thoughts on that?
Yeah, it's astonishing. And even first time we did the numbers, because obviously no one publishes a number and says, here's current steam demand. It's behind the fence. But we did bottom up and top down market size estimates. And we ended up roughly around 32 gigawatt thermal for industrial steam here versus, like you mentioned, 10 gigawatt electrical for the power market. So it's huge, but it's also complex. It's a heterogeneous market. You've got high pressure steam, low pressure steam, saturated, superheated, so all kinds of applications. But it's so big that even if you can address only a small part of it, it's already very material. And that's exactly what we're seeing here. Natural gas is really cheap in Canada, even cheaper than in the US. So that's hard to compete against. But we mentioned CCS. Depending what the alternative is, there are really nice niches. And if I call something a niche in such a big market, like a 5% niche is 1.6 gigawatt. If you electrify that, for example, with solar at a 20% capacity factor, then that 5% of industrial heat electrification can drive 8 gigawatt of solar deployment. So it's huge. And to me, that just outlines an opportunity. If we find profitable niches in big markets, we can go with a market-led deployment. And that lets us that'll keep us busy for a while, given the overall size. It maintains affordability. And it's like, so recently from Michael Liebreich, he had a really interesting piece on a pragmatic climate reset and thinking like a tortoise more than the hare. Let's just deploy what we can right now, what works, and what's ideally already economic. And that to me is a primary example of that.
I agree completely. And another topic in this, kind of thinking about it, and something we've talked about, is roughly 40% of industrial emissions come from generating heat and steam. I don't know that people know that or think about that, but how much progress could we make using solutions that already exist today, as you just kind of alluded to there?
It's again the question on, what can we do? What should we do? Technically, we can address virtually 100%. But a lot of these solutions may be just so far out of the money that they don't make sense right now. For example, I mean, it's less and less so, but if you looked at heating, you could in theory heat everything with hydrogen. Then again, prohibitively expensive in almost every setup. It's a bit like heating your house with scotch. It's like, it's technically possible, but should you do it? Well, maybe not. So it brings us back to, let's start with simple, start with the things that need minimal subsidies. Help maybe if regulators, governments can help cut some of the red tape, simplify the rules and streamline them. And then let industry follow with a market-led deployment.
I love it. And just kind of like encapsulating that, sort of start with simple and kind of going through it. Then the question becomes sort of how to scale some of those simple ideas and solutions. And you've shared that profitability is the real driver. So let's explore that a bit. And one of the things you shared with me is like, money isn't the obstacle if the business case is strong. Why is profitability the ultimate accelerator for change?
I don't want to trivialize it. So getting investment dollars, done that a lot also in the big companies I worked for before, so advocating for it. It's never trivial. But let's pick, going back to the LNG example, the US went from a base of 0 to being the world's largest LNG exporter in the space of a decade. With virtually no subsidies there. And the background is, of course, you had cheaper feed gas with the shale gas revolution, but so do many places around the world, especially the Middle East and other places. Really what came in was the business model that underpinned this, the tolling approach that was taken over there. And that all of a sudden ensured profitability for key value chain players and enabled to bring in new players, in that case, these midstreamers like a Cheniere, instead of just the traditional oil and gas companies to build this. It unlocked many pathways for capital to come in. The opportunity was profitable. And we have hundreds of billions of dollars mobilized. So I think that just showcases if profitability is sufficiently de-risked, we can see massive growth in a very short amount of time. So I don't think just the amount of dollars required is the primary obstacle. The primary obstacle is to make it profitable. And I think if we look at battery and solar scaling, we're starting to see similar effects evolving there.
Agreed. And thinking about that, so you mentioned the LNG industry scaling rapidly in the US. Once those economics really worked and the profitability was there, any other lessons that can be applied to renewable and clean heat solutions as we think about that and look at that as a kind of a case study, I guess?
Yeah, indeed. And that's back to these points around flexibility, business model, and modularity. Modularity is already a feature here. So the more we can look for projects that can be deployed in a modular way, the better.
Yeah.
Finding the right business models, that's really our bread and butter business here at Arder, because that's the commercial angle we bring.
Yeah.
And then also try to find where flexibility adds value. If we analyze this correctly for each of the clients, we can come up with pragmatic and economic roadmaps to deploy this in a non-disruptive way. Very important for industrials. They usually want to be first to be second. They don't want this to be disrupted. They want to look at other projects that have been done profitably before. So it's really about identifying the right opportunities, looking for modularity wherever we can, finding the right business model, and then delivering flexible solutions.
Yeah. Another example, just kind of looking at out Alberta specifically, times when electricity prices hit zero because renewable generation exceeds demand. How could that be turned from a market challenge into a business opportunity?
Our local power market here is very, very interesting. It's deregulated. We don't have many interties. It's been historically an energy-only market. We have a very high base of cogeneration assets, gas-fired cogen. These are, however, quite inflexible as well. And then we had a very large renewables growth. So what that often leads to is that because of that high base of inflexible cogen, if the wind blows and the sun shines, we end up with situations of excess supply very often, or grid curtailments.
Yeah.
And as a result, you end up with these $0 prices. We have a price floor right now of $0. We'll go to minus 100 by 2032. But right now, zero is the base. And we had, up to end of August, 6% of all hours were priced at $0, 355 hours at zero. We had in Q2 alone 310 gigawatt hours of curtailment, either due to grid constraints or due to excess supply. Now, what comes with that, of course, is the best cure for low prices are low prices. What's a pain for generators can turn into an opportunity for flexible loads or for storage.
Yeah.
And if you then look, for example, at the daily cheapest 8 hours year to date so far, that was around 14 Canadian dollars a megawatt hour only.
Yeah.
So that's just under 1.5 cents per kilowatt hour. So if you're a flexible load, and like thermal storage would be one such example, you can make really maximum use of these very low, intermittently very low prices.
Yeah. And kind of getting into that, so one of those solutions you work with is electrothermal energy storage. For people who have never heard of it, can you just explain it a little bit and what it is and how it works?
Yeah, so in short, it's a highly capital efficient way to transform intermittently cheap and clean power into base load heat. So it's basically power in for a few hours a day, depending on technology, but getting rateable, dispatchable, basically base load heat or steam out 24/7.
Yeah. And so you've described the technology. I love, it's simplified, but I love it. And I'm going to say it as a giant toaster in bricks. But before we get to that image, set the scene for us a little bit. What problem is this technology solving? Why is it so relevant right now? Just tell us a bit more about it.
So it comes back to those points that we discussed on the grid. So we have low cost, low emission electricity on the grid, but intermittently only. We have in most markets, including here, large volatility.
Yeah.
But for certain hours, you have this excess. And this technology can come in almost as a bottom feeder and absorbing that excess power really cost effectively help stabilize the grid. Or the power can even come from behind the fence, behind the meter generation, and then be converted into heat, and then solving the challenge where industrials want really cost-effective, cost-efficient heat and steam at reliable pricing as well, driving really affordability and resilience.
Yeah. Now tell us a bit about the giant toaster and bricks analogy. Explain it. Like, so where does it come from? Why does it capture the essence of the technology so well? And help us just better understand what the technology actually does.
Yeah, indeed. There are several approaches to thermal storage. What they all have in common is electrothermal storage, power in, intermittently heat out. For storage, there is molten salt, molten metals, glowing carbon, all kinds of things. And the technology we've been focusing on comes from a provider in California called Renewable Energy.
Yeah.
And theirs is indeed best described as the toaster covered in bricks. The toaster is electric resistance heating. So they're using heater wires that come from the steel industry. Those have been around for decades. They start glowing like a toaster when you turn them on. Mm-hmm. They're surrounded by refractory brick. So this is basically a ceramic. Comes also from the steel industry. The formulation is around since the 19th century. It's just a different form factor. Yeah. And they start glowing it up to 1,500 degrees centigrade. So really hot. They got air channels in them. The whole thing's enclosed in a building, of course, but they got air channels. A circulating industrial air blower blows air through it. The air gets blended to the same temperature or similar temperature as what a gas burner would achieve. So around 600, 650 C. Goes into an industry standard steam generator, so a Hersig or Otzig, and generates then the same steam profile that industries is used to. So it's a very simple approach. The good thing is it has, I would call it just minimum innovation.
Yeah.
Because it combines technologies that have been around for a long while. The combination never made sense in the past, because why would you convert pure exergy, almost electricity, back into heat? Yeah. But with these market developments, it starts to make sense. And importantly, also, it uses the steam generators that are already out there. So you don't need new boiler certifications in the right markets and so on. And then it has there's no fire risk, no toxic release risk, no thermal runaway risk with this approach, which is very important to industrials, because otherwise you're not even allowed into their processes.
Any other benefits of that technology versus some other options that are out there? Just kind of thinking about that one in particular that, I hadn't really heard much about until we had a conversation and kind of talking through it. What are the other benefits to it? Yeah,
I would say between the different thermal storage approaches, personally, I don't think there is a winner takes all. It's rather a space for all market. It's very heterogeneous. The Rondo technology is very much focused on large scale industrial steam demands. That's what we're primarily addressing. And it's really great for it. To give you an idea, the units, they're big. Like their standard sizes are 100 and 300 megawatt hours of storage. So it's a building size thing. If you compare it with a current, like a Tesla Megapack industrial grade battery, the 2XL has 3.9 megawatt hours. Now that's electrical, not thermal. So apples and oranges. But this is like up to 80 times that size for energy wise. So it's huge. Yeah, that's really an advantage if you want to go big, and they're designed as drop-in units. But as I mentioned, there are other technology providers as well. Another advantage of like the Rondo approach is you can even use it in a CHP, so cogen configuration. So you get part of your energy back as rateable 24/7 baseload electricity. And you still get low pressure, low temperature steam out that you can use for industrial processes. So it's really it depends approach. But since industrial heat is such a huge market, huge field of applications, there are quite a lot of areas where it can work well.
Yeah, I love it. What kind of other project economics in terms of payback period or return on investment are needed to get industry decision makers on board and for that to continue to scale?
Yeah, that's indeed the crux. The requirements are, I would say, very client specific. Of course, no one wants to lose money. So I would say if it goes below zero, virtually impossible. Yeah. Less than 5-year payback period, generally great. More than 10, hard. But risk is really the key. If we have a lot of market risk, or especially a lot of stroke of the pen risk, like political risk, like with the example with the refinery, even a 5-year, 4-year payback period may be really hard to stomach. Whereas if you can secure certain parameters via contracts for differences or otherwise, longer paybacks may also really work. So it's an it depends answer. And our focus is a lot on identifying those cases and then supporting that deployment. And really with this, I'd mentioned already, there is generally a first to be second approach as well. That's where for the initial projects, grant support is key. And here in Alberta, we really have some great options there with what's called Emissions Reductions Alberta Innovates, and I think other markets have similar opportunities, but they become really key to get the first of a kind project off the ground.
Yeah, and I think you mentioned a couple earlier, but outside of oil and gas, which sectors are best positioned to adopt thermal storage first?
Yeah, a lot of industries use steam. It's pulp and paper, fertilizer production, chemicals, food manufacturing, clothing, and so on. Where does it work best? Really, it's another sweet spot is where those industries can pass on any green premiums to their customers or even make a margin. And you see that as a result. For Rondo, for example, they've got 2 projects with Diageo. For one is a whiskey factory. I think they run a cocktail factory. And I think H&M entered there as a strategic partner. So for these companies, if they can present themselves as having green production, that also avoids them having to absorb any green premium that might be in there.
Yeah, it's super cool. And even when solutions are ready, progress can still stall or slow if industries don't work together. I love this topic. We talked a little bit about this and talking about bridging those divides. So you've said, oil and gas, power, renewables often operate in separate bubbles. Why is that a barrier to progress? Like, tell us your thoughts on it.
Yeah, and we have too many echo chambers. And lately, unfortunately, also too much of almost a culture war between renewables and oil and gas, which I think really is not helpful, the polarization, and just purely looking at economics as well, it leads to suboptimal solutions. There's a lot to be learned out there from each other and provide synergistic solutions. And to give you an example, I was at a conference earlier this year. An audience member just asked, well, at Arder, why do you spend so much time? Why do you waste your time on the oil and gas industry?
Yeah.
Isn't that industry shrinking anyway, or it should shrink at least, and it'll go away? And if we look at it, the reality is, certainly here in Alberta, oil and gas production is growing. Even in the oil sands, it's growing. But even taking another perspective, even if we assume that 90% of it went away, the residual 10%, just the industrial heat demand from that 10% is still in gigawatt range.
Yeah.
So it remains a big challenge, and it remains a big market even in that scenario.
Right.
So I think we just need to, be open to it, collaborate, and just see what we can do, and especially in applications that already work economically.
Yeah, I agree wholeheartedly. And just thinking about the lack of cross-industry connection, how does it cause us to maybe miss low-hanging fruit, or what else are we missing when we don't collaborate across those different industries? Yeah,
to give you one example, like, again, oil and gas example, but if you look at it, a lot of the talk is often around, like, for CFR side, so the renewable fuels, on biofuels, carbon capture, how we can reduce emissions. But low-hanging fruit is, for example, behind-the-fence solar. Now, Shell seems to have figured it out. They built a 58 megawatt behind-the-fence solar facility at their Scotford refinery here in Calgary, in Alberta, near Edmonton. And, well, we don't know the economics. We've done it back of envelope, and it looks really highly attractive.
Yeah.
Doesn't seem copied at other facilities yet very much. So there's certainly a lot that we can learn and that we can implement. And the broader we look across the opportunity space on what could work, is it a solar behind the fence? Is it power to heat? Is it maybe in other applications that might be the biofuels or CCS? But the less we narrow our focus down to one or two areas that may be closer to home, but look really broadly and learn from the other industries, I think we're all better off.
Yeah, I agree. And I think a lot can happen, progress can happen when we're open-minded, curious, when we're open to collaborate, all those sort of things. You shared a story with me about even a rooftop solar. That event sort of changed your own assumptions. And so I think it's a great example. So could you tell us that story and then ultimately what it taught you?
Yeah, so when talking about being too deep in an echo chamber and not looking broadly enough, I'll fully include myself. And that was really an eye-opener for myself here. A few years back, my neighbor and I were having a beer, and he told me that he wanted to get solar on his roof, and he got a quote. And I was so convinced, I just told him, look, nice idea if you want to waste your money. But you know what? These things are so uneconomic. And he said, well, it looks quite good. And I told him, no, it was around Christmas. So I said, just send me your quote. I'll spend a bit of time and I can show you on a spreadsheet how it can never make sense. And I was so confident. So I built a quick spreadsheet, just looked up the parameters, and it showed up with an almost 10% IRR. And I thought, well, this can't be true.
Right.
And spend another 2 weeks diving deeper into aspects from, okay, what kind of inverters do you need? What are clipping ratios? How about the snow cover? And so on. But the return rates barely budged. So I called up a friend of mine, very smart commercial and finance guy, also in oil and gas. Because I said, like, hey, can you vet this? Here's what I found. And he told me also, it's like, makes no sense. You got a mistake in there, I'm sure. Just send me the stuff. Long story short, now all three of us have got solar on the roofs because the numbers were so robust. And the two other guys, they even got EVs because they dove deeper into the economics of EVs. And it's like, well, we drive so much on the weekends, it just pays for itself. And to me, this really showed I was myself so convinced. Yeah. And I think often when we see these, sometimes you see these debates where people almost say, oh, the industry just tries to undermine these economics. I think often it's just, we're so convinced and we come from our echo chambers. Yeah. Often we don't challenge ourselves enough here. And just, if we come in, challenge own assumptions, let the data speak for itself. Yeah. I think we can all be better off. And here, I must say, I'm personally economically better off for that. So.
I love that. That story's so great. I appreciate you sharing it and just the realness of it, and I think we are guilty even within the industry sometimes of we are in these little echo chambers and making assumptions, and a lot of good can come out of when we break out of that and start being open. So I think it's just a great example. What's maybe another example where collaboration between traditionally separate industries created an unexpected opportunity?
I think also, and I didn't want to be negative there in the past, we see good examples emerging there really. Within thermal storage, for example, one of the key investors in Rondo is Aramco. So it's the Saudis, the world's largest oil and gas producer. And they even signed a gigawatt scale MOU for global deployment of the technology. Yeah. So they're investigating that now very actively. Shell, for example, invested into another ETS company, Kraftblock out of Germany, and made a seed investment into Antora in the US. So we do see these large players who spend sufficient time on the topic, seeing an opportunity and really committing their dollars to such deployments and learning from how they can work.
Yeah, love it. And I think we'll continue to see more of that. I think we are seeing more of that collaboration and things like that happening, and just to put it out there, just encouraging more of it and people to be open to it. So we've looked a bit at the challenges and opportunities in front of us today. I want to imagine, kind of what the next decade could look like if just 5% of Alberta's industrial heat demand shifted to electrified thermal storage. What would that mean for emissions and the power grid?
So if we take that 5% example, we ended up at roughly, call it 1.6 gigawatt thermal. Want to electrify that. The efficiency is high because it's power to heat and you stay with heat. So you're at north of 95% efficiency. So again, that leads at 20% capacity factor to 8 gigawatt of solar, for example, enabled. Yeah. But importantly, it takes out the power when the grid needs it least. And if you deploy the technology upstream of grid bottlenecks, you actually help to debottleneck the grid. You drive up grid capacity factor. So it actually helps with affordability as well. And I think that's really crucial in our times as well to maintain the affordability of solutions we have. So it leads to grid stability. And looking at emissions, these 1.6 gigawatt thermal with 80% efficient gas boilers, what you would save is about 3 megatons per annum in terms of scope 1 emissions. Your scope 2, of course, depending on the source. But yeah, your incremental supply should certainly be from renewables for that. And yeah, for the 5%, 3 megatons per annum.
Yeah, it's huge. Incredible. Just that, again, even a small percentage. What policy or market changes would accelerate adoption of the technology?
I think the two biggest ones would be one, levelizing the playing field among technologies. And the nice thing is it looks a bit counterintuitive if ITCs for other solutions stay. If you bring them up for thermal storage to a similar level, you actually save money, because then industry is also incentivized to pick the solution that has the lowest overall cost. Yeah. But whichever way you do it, levelizing the playing field is crucial. And the second one is, it's a bit more in the weeds, but it's actually very important. It's the carbon accounting rules. So if you look here, if you take power from the grid in Alberta for carbon accounting, you usually get hit with the average grid intensity factor, emissions intensity factor. That's here. Last quarter was 370 kilograms per megawatt hour. So let's call it close to 400 kilograms per megawatt hour. An 80% efficient gas boiler has about emission intensity of 227 kilograms per megawatt hour thermal. So replacing 227 with 370 makes, of course, 0 sense.
Yeah.
But the crucial part here is that you would only switch on these units whenever there is excess supply.
Yeah.
So it's during hours when we have lots of renewables on the grid. So it's these hours where, and we get more and more hours where the hourly incremental emissions intensity is 0 or is very low. So if you can change the carbon accounting in a way that you get hit with the hourly average or hourly incremental carbon intensity rather than a broad average over the whole month, that would make a huge difference in just accounting for what's really happening rather than an average. And the numbers, they already get calculated. They get published by what's called the MSA here. It's a market surveillance administrator. So the additional bureaucracy should be relatively low, but that would make a big impact. Because right now, it even looks like you actually pollute more if you electrify.
Yeah, no, it's cool and cool perspective just to understand. One of the things as we get closer to time, so you've called this the most exciting time in energy in 2 decades, and I agree. What makes it so exciting for you personally?
I mean, I love energy. It's just the area that really, it drives whole economies, it drives human prosperity, and it's just, it has so much impact. And we're at a time where we not only see a lot of growth, but we see all these technologies coming in that start to disrupt the status quo and that are reshuffling the deck. And I recently heard that quote. I think it was Laurent Segalin who said, just, you know, you're in a revolution if the experts keep being wrong. And, and we see that so often. If you look at forecasts for, I'll pick solar, for solar deployment curves and what's actually happening, I think we quite clearly are in a revolution. Same for batteries. So it's a great chance to have an impact, and for power to heat in particular to be in from the ground floor as this develops.
Yeah, love it and agree. 10 years from now, how do you think people will view the role of industrial heat in the overall energy picture? Like, what does it look like 10 years and beyond?
I think power to heat will win purely for economic reasons, and it will just be the new normal. Now, it's not AI data centers or fancy new aviation fuels, so it'll probably not catch too many headlines, but it'll rather be the unsung hero of the transition. And it'll do it in a way that's actually profitable and beneficial for industry.
Absolutely. Final question. Any other kind of parting words of advice, things you didn't get to share, things you want to leave the audience with?
Yeah, I just think it's a tremendous opportunity. It's a tremendous time to be out there and in this market to make a difference. And there are so many solutions that can really work together. So for us as well, we're always looking for chances to collaborate with others. So if any of the listeners have any particular questions or ideas, always happy to engage. You'll find me on LinkedIn, for example, or through our webpage, arder.ca, and always looking for chances to collaborate with others and create value.
Yeah, great way to wrap up. And I will link some of those in the show notes as well that listeners can go check out. Jan, thank you for bringing clarity to part of the energy transition that often flies under the radar. Your focus on simplicity, profitability, and breaking down silos offers a fresh and practical framework for action. To our listeners, thank you for tuning in as always. If you enjoyed today's conversation, please subscribe to Green Giants, leave us a rating, and share the episode with someone who cares about the future of energy. With that, we will see you soon.
This episode of Green Giants, Titans of Renewable Energy, was brought to you by Lee Group Search. If you enjoyed today's discussion and are looking to recruit top talent for your company or find your next career opportunity in the renewable energy sector, visit leegroupsearch.com. Let's continue driving the future of clean energy together. Until next time, keep pushing toward a greener future.